Trig identities have multiple angle identities as well, and multiple angle identities can go in several different forms, such as the double angle identities for starters. And I'd like to start a little bit by showing you where these double angle identities come from. First of all, if you had the sine of 2 theta, all you're doing is using the sum formula for the sine and plugging it in the sum formula and ending up with combining these two like terms to get the right side. The cosine 2 theta is the same thing as cosine theta plus theta using the sum formula. And when you do that, you would get this, which combines to cosine squared theta minus sine squared theta. Now, once you have this particular identity, next what you can do is just plug in your Pythagorean identities. So for example, cosine squared equals 1 minus sine squared, and that would get you the third one. And if you had sine squared, that's 1 minus cosine squared, which would get you to this identity. So that involves double, one last thing, to get the double angle formula for tangent, basically you're putting sine 2 theta over cosine 2 theta, and then dividing top and bottom by cosine squared, and you'd end up with this. Other type of multiple angle identities, power reducing identities. So you can solve for the sine squared here, and when you solve for the sine squared, subtract 1, divide by -2, you end up with this. And you can also solve for the cosine squared, add 1, divide by 2, get this. And you can get the tangent squared. And the way that you do that is you would put the sine squared over the cosine squared and end up with this. These power reducing identities on the identity sheet can be used to get half angle identities. Now, what's important to notice first of all is you could replace this theta with theta over 2. So if you did theta over 2 here, this would be theta over 2, which means this would just be the cosine of theta. And that's what they did to get these half angle identities. They replaced theta with theta over 2 and took the square root of both sides. That's how you get the sine of theta over 2, the cosine of theta over 2, and then the tangent of theta over 2. There are a lot of identities that you can use to simplify and evaluate. So real important, keep your identity sheet handy, and that will make these substitutions much simpler.